Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you get everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or building your CI pipeline, they just launched dedicated CPU instances. Go to pythonpodcast.com/linode, that's LINODE, today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And bots and automation are taking over whole categories of online interaction. Discover.bot is an online community designed to serve as a platform-agnostic digital space for bot developers and enthusiasts of all skill levels to learn from one another, share their stories, and move the conversation forward together. They regularly publish guides and resources to help you learn about topics such as bot development, using them for business, and the latest in chatbot news. For newcomers to the space, they have a beginner's guide that will teach you the basics of how bots work, what they can do, and where they are developed and published. And to help you choose the right framework and avoid the confusion about which NLU features and platform APIs you will need, they have compiled a list of the major options and how they compare. Go to pythonpodcast.com/discoverbot today to get started and thank them for their support of the show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference. Go to pythonpodcast.com/conferences to learn more and take advantage of our partner discounts when you register. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the newsletter, and read the show notes. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host, as usual, is Tobias Macy, and today I'm interviewing Dmitry Petrov about DVC, an open-source version control system for machine learning projects. So, Dmitry, could you start by introducing yourself?
Sure. Hi, Tobias. It is a pleasure to be on the show. I am Dmitry Petrov. I have a mixed background in data science and software engineering. About 10 years ago, I worked at academia, and sometimes I say I worked with machine learning for more than 10 years, but you probably know that 10 years ago, machine learning was mostly about like linear regression, logistic regression, and this is pretty much what I was working on. And then I switched to software engineering, and I write some production code. At that time, data science was not a thing. Around 5 years ago, I switched back to quantitative area. I became a data scientist at Microsoft, and I saw how modern data science looks like. Recently, I'm actually back to software engineering. Today, we are working on DVC, and I basically build tools for machine learning.
And do you remember how you first got introduced to Python?
Yeah, it happened in 2004, I believe, and it happened accidentally. I got into an internship during my master program, and I worked on a Python project. It was my first scripting language. I don't count like Lisp in my functional programming class, of course. And it was Python 2.2, and then we switched to 2.3. I have spent a number of sleepless nights debugging Unicode issues in Python 2. If you work with Python 2, you probably know what I'm talking about. And later, I found myself using Python in any single research project that I was working on. We were still using MATLAB for machine learning. It was quite popular 10 years ago. We use plain C for kind of a low-level software. Let's imagine when we need a driver to track some signals. But in general, Python was a primary language in my laboratory. When I work as a software engineer, my primary language was C++, but I still use Python for kind of ad hoc project, for automation. At that time, there were a lot of discussion about Python versus Perl. And to me, it was not a question, so I use Python all the time. And during my transition back to data science, Python became my primary language because, like, in data science, it's kind of one of the top languages that people use. Today, we build tools for data scientists, and we use Python.
And so one of the tools that you've been working on is this project called DVC, or Data Version Control. Can you start by explaining a bit about what it is and how that project got started?
DVC is basically a version control system for machine learning projects. You can think of DVC as a command line tool. It's kind of a Git for ML. What it gives you, it gives like three basic things. First, it helps you to track large data files. For example, 10 GB data files, 100 GB data sets, ML models. And it helps you in versioning pipelines, machine learning pipelines. It's not the same as data engineering pipelines. It's kind of a lightweight version pipelines. And DVC helps you to organize your experiments, make them self-descriptive, self-documented. Basically, you know everything, how a model was produced, what kind of commands you need to run, what kind of metrics were produced as a result of these experiments. And you will have all this information in your Git history. And DVC helps you to navigate through your experiments. From technical point of view, we use Git as a foundation. So DVC works on top of Git and a cloud storage. You can use S3, you can use Google Storage or Azure, or just like random SSH server where you store data. And DVC basically orchestrates Git and cloud storages. And you also ask like how DVC got started. And this is actually a separate story, because initially when we started the project, we were not thinking about Git for ML. What we were thinking about was data science experience, what is the best practices, and we were inspired by ideas of data science platforms. You probably heard about Michelangelo, a data science platform of Uber. You probably heard about Domino Data Lab. And today, actually, every large technology company has own data science platform, because they need to work somehow in a large teams, right? They need to collaborate. And software engineering tool set is not perfect for ML projects, for data science projects. But when we are looking at the platform, we are thinking like how the platform of the future should look like. How we can create a platform which each data scientist can use and which can be like widely adopted, highly available. And we come up with this idea, the kind of a principle of data science platform of the future. It has to be open source. This is the way you can be like community driven. This is a way you can kind of create like a common scenario which everyone data scientist can use. And it has to be distributed. It's important because sometimes you work on your desktop because you have GPU, for example. Sometimes you still need your laptop to work. And sometimes you need a cloud resources to run like a specific model without, for example. You need huge amount of memory. And it is important to be everywhere. So with this kind of principles, we come up with the idea, why don't we reuse Git as a foundation for data science platform for our tool? And then we realize it's very close to idea of versioning. We just need version data set, we need version experiments. And this is how DVC got started.
And so you mentioned that the traditional version control systems that are used for regular software projects aren't quite sufficient for machine learning because of the need for being able to track the data sets along with the code itself and some of the resulting models. So can you walk through some of the overall workflow of working with DVC and how that differs from just a regular Git workflow for a software engineering project that might be focused on like a Django application?
First of all, we need to understand what is the difference between software engineering and machine learning. And machine learning is driven by experiments. And the problem is you have a bunch of experiments. You have dozens, sometimes hundreds of experiments. And you need to communicate with the experiments with your colleagues and basically with yourself, because tomorrow you won't remember what happened today. And in 1 month, there are no way you will remember what you have done today and why this idea produced such a poor result. You need to track everything. Like in many cases, you can be in the situation when like one of your colleagues comes to your office and says, hey, you know what? I have spent like 2 days trying this idea, and you know what? It didn't work. And you like, yeah, I have tried the same idea like 2 weeks ago, and yeah, I know it didn't work. And it's hard to communicate these ideas because you have just dozens of those, sometimes hundreds of those. And this is the difference. You need to framework to communicate by huge amount of ideas, huge amount of experiments. In software engineering, workflow is absolutely different. You have a limited amount of idea. It might be like feature request and bug fix. I can say one kind of a controversial statement, but in software engineering, you almost never fail. If you decide to implement some implement some feature, or fix a bug, you create a branch, and with like in 9 cases out of 10, the branch will be merged to your kind of to mainstream, right? You can fail in terms of quality of software that you produced. You can fail in terms of budget that you spent because you thought it was like 1 day project, and you end up like spending 2 weeks of implementing this feature. But finally, it will be merged. In data science, it's opposite. You try 10 ideas, one works as the very best, and the rest didn't work. But you still need to communicate all of those. DVC basically helps you to do this. It helps you to version your experiments. You see kind of you see a list of your experiments. You see metrics which were produced. You see the code which was used for this particular experiment for this particular version of the data set. And this worked way better than, for example, Excel spreadsheet. Because today, many teams use just an Excel spreadsheet to track their experiment. So this is the basic difference. Self-documented experiments, a clear way of collaborating on experiments and look into the result. Data versioning, it's kind of a separate thing, which is important for experiments. It's must-have for experiments. And sometimes people use DVC just for data versioning. Usually, for example, engineers who work on deployment side, they use DVC to deploy the model. Sometimes the data engineers or data scientists use DVC just to version their data sets. Sometimes people use DVC as a replacement for GitLFS, because GitLFS has some limitation, and DVC was optimized for like dozens and hundreds gigabyte range.
And for the types of experiments that you're working with, I know that some of the inputs can be in the form of feature engineering, where you're trying to extract different attributes of the data, or changing the hyperparameters that you're tuning to try and get a certain output of the model. So can you discuss how DVC is able to track those and some of the communication paradigms that it enables in order to make sure that you don't have that replicated effort of lost time and energy with people duplicating the same work because of not being able to identify ahead of time that that particular set of features and hyperparameters and data inputs have all been tried together?
From data files point of view and data sets point of view, DVC just track them. So your feature, so basically DVC treats every file as just a blob, and it usually doesn't go into semantic of your data files and structure of your data files, and the same with a model. So a model is just binary, and what DVC can understand that the model was changed. It can understand that this particular version of the binary file was produced on this particular step, and this particular input was consumed. But it does not go inside kind of a features. It doesn't go into kind of a semantic of the data.
And as far as the just overall communication pattern, what are some of the things that a data scientist would be looking at as they're working within a project that's managed through DVC to make sure that they're not duplicating that effort? Any sort of signals that they would be identifying that would be lost otherwise with just using just Git by itself?
Yeah, first of all, the structure of experiment. This is what super important in data science. You need to know, I mean, not only in data science, in engineering is pretty much the same. You need to understand what kind of code was used, what exact version of your code, and what exact version of the data set was used. This is how you can trust to an experiment that you did, like, let's say 3 weeks ago. And one more thing is metrics. If you know that this code with this version of the dataset produce that particular value of the metric, it creates your kind of a trust. You don't need to redo this job again. If you see this result in your Excel spreadsheet, it might be some discrepancy, right? It can be some like error in your process, and you might end up redoing the same stuff. And for documentation, you can use just a git commit. When you commit your result, which means you commit a pipeline, you commit a version of your data set and output results, you put a message. And message in a Git it's a very simple form of your documentation, of your project documentation. And this is actually a very powerful form. What DVC does, it basically make it work for data project. Because in a regular workflow, you can commit code, but you don't have a connection with data. You don't have a clear connection with your output metrics. And sometimes you don't even have a connection with your pipelines, because this commit might be related with one particular change of one particular part of pipeline, not the entire pipeline.
And as far as the metrics that you're tracking, can you discuss a bit about how those are captured and some of the ways that they factor into the overall evaluation and experimentation cycle to ensure that the model is producing the types of outputs that you're desiring in the overall project?
DVC is, first of all, DVC is language agnostic tool and framework agnostic. And DVC is metrics agnostic as well. It means that we track metrics in a simple forms of text files. Your metrics is a TSV file with some header, or CSV file, or JSON file. When you just output, we had 5 metrics with that values. And DVC allows you to look at your entire set of experiments, which metrics way was produced. You can find that this idea, for example, which failed because a metrics was not perfect, actually produced a better, another metrics had a good value, and you probably need to dive into these experiments. So it shows you metrics across your branches, across your commits, and it basically helps you to navigate through your complicated Git structure tree by metrics. It's kind of a data-driven way to navigate through your Git repository. And in a data project, you might have thousands of commits, hundreds of, or dozens of branches. And DVC basically helps to navigate through this complicated structure. This is why we need metrics. This is why DVC has a special support for metrics.
And so is there built-in support for being able to search across those metric values and compare them across branches, or is that something that you would need to implement on a per project basis as far as a specific function call that determines, whether it's a positive or negative value across those different comparisons?
Today, we basically show the metrics. If you need to navigate, you need to probably implement something on top. But I won't be surprised if we implement some logic, metric-specific logic. For example, show me maximum value of this particular metrics. Show me some maximum value like of those combination of those metrics, something like this.
And in addition to version control that's typically used for regular software applications, there are also a number of other types of tooling that are useful to ensure that the projects that you're building are healthy and that you don't have code regressions. So things along the lines of linting or unit test support. And I'm wondering, what are some of those adjacent concerns that should be considered when you're building machine learning projects, and any ways that the work that you're doing either with DVC or any of your other projects tie into that?
It's a good question, because in general toolset in data projects, it's not on the same state as a toolset for software projects, right? It was an interview with you did with Wes McKinsey about like a month ago, and he said in data science we kind of still in the Wild West, and this is actually what is happening. We don't have a great support for many scenarios, but from toolset point of view, what I am seeing today, it is quite mature in terms of algorithms, because we have PyTorch, we have TensorFlow, we have like a bunch of other algorithms like random tree-based algorithms. And today there is a kind of a race of online monitoring tools. For example, TensorBoard, when you can report your metrics online when you train and see what actually is going on the training phase right now. It is especially important for deep learning because like algorithms are still quite slow, I would say. And there are a bunch of commercial products in this space. And MLflow, one of open source project, which is becoming popular, which helps you to track your metrics and visualize training process. So this is kind of a trend today. Another trend is how to visualize your models, how to understand what is inside your models. And again, there's a bunch of tools in order to do this, but state of this tooling, it's still not perfect, I would say. In terms of unit tests, I mean, you can use just a regular one, right? Just a regular unit test framework, but I couldn't say it works really well for ML projects specifically. But what I have seen for many times is unit test, or probably not unit test, but functional test for data engineering. In data engineering part, when new set of data comes into your system, you can easily understand, you can get basic metrics and make sure there are no drift in the metrics, there are no big changes in the metrics. So this is how unit test, or test at least, can work in the data world. But toolset in general, it's kind of a still Wild West.
And moving on to the data versioning that is built into DVC, as I was reading through the documentation, it mentions that the actual data files themselves are stored in external systems such as S3 or Google Cloud Storage or something like NFS. And so I'm wondering if you can talk through how DVC actually manages the different versions of that data and any type of sort of diffing or incremental changes that it is able to track, or any difficulties or challenges that you faced in the process of building that system and integrating it with the software control that you use Git for in the overall project structure.
Yeah, of course, we don't commit data to Git repository. We push data to your servers, to your clouds usually, and you can reconfigure the clouds. As I said, we treat data as binary blobs, and for each particular commit, we can bring you like actual data sets and all the data artifacts that were in use. We don't do any diffs per file because you need to understand semantic of a file in order to do diffs, right? It's not a Git. In a Git, every file is a text. It makes sense to make a diff. In data science, you need to know what exact format of a data file you use. However, we track directories as a kind of separate types of structure. If you have a directory with, let's imagine, 100,000 files, and then you added like a few more files into directory and committed this as a new version of your data set, then we understand that only small version of a file was changed, only like, let's say, 2,000 files was modified and 1,000 was added. Then we version only diff. So you can easily add your labels in a daily base, in a weekly base, without any concern and for the size of your directory. We do this kind of optimization. And another important optimization that we do is optimization in your workspace. When Git checkouts files from an internal structure, it creates a copy in your workspace. However, in a data world, sometimes it just does not make sense because you don't want to create like a copy of 100, let's say, gigabytes of data, another copy. And we optimize this process through hard links and ref links. So you are not having a duplication of your data set. So you can easily work with hundreds of gigabytes, dozens of gigabytes without this kind of concerns.
For somebody who is onboarding onto an existing project and they're just checking out the state of the repository for the first time, is there any built-in capacity for being able to say, I only want to pull the code, I'm not ready to pull down all the data yet, or I just want to pull down a subset of the data? Because somebody who's working on a multi-hundred gigabyte data set doesn't necessarily want to have all of that located on their laptop as they're building through these experiments. And just curious what that overall workflow looks like as you're training the models when you're working locally, how it handles interacting with these large data repositories to make sure that it doesn't just completely fill up your local disk.
Yeah, this is a good question. Yes, we do this granular pull. We kind of optimize this as well. And you, as a data scientist, you can decide what exactly you need. For example, if you'd like to deploy your model, which probably within like 100 megabytes, right? You probably don't need to waste time to full 100 GB data set, which was used in order to produce model. And then you can specify, I need only this data file. Like clone your repository first with a code and metadata, and then say, I need just a data file. I need just a model file. And only model file will be delivered to your production system, to your deployment machine. And the same with data sets.
And there are some other projects that I've talked about and talked with people who are building it, such as Quilt or Pachyderm, that have built-in support for versioning of data. And I'm wondering if you have any plans currently to work on integrating with those systems, or just the overall process of what's involved in adding additional support for the data storage piece of DVC.
Yeah, for some of those systems, integration can be done like easily. For example, Pachyderm, it's a project, it's mostly about data engineering. They have a concept of pipelines, kind of a data engineering pipelines, and DVC can be used in data engineering pipelines. It has notion of ML pipelines. It's kind of a lightweight concept. It's optimized specifically for machine learning engineers. It doesn't have all this complexity of data engineering pipelines, but it can easily be used as a single step in engineering pipeline. And we have seen that for many times when people take, for example, DVC pipeline and put that inside Airflow as a single step. And with this kind of design, it's actually a good design because you give a lightweight tool for ML engineers and data scientists so they can easily produce a result and they can iterate faster in order to create theirs job. And you have a production system where DVC can be easily just injected inside. And there is a term, I don't remember what company it used, Netflix probably. They use term DAG inside DAG, which means you have a DAG of data pipelines and you have a ML DAG for one particular problem, and then basically inject a lot of like ML DAGs inside a data engineering DAG. So from this point of view, there are no problem to integrate. There are no issues with integration to Pachyderm or Airflow or other systems. Regarding Quill data, they do versioning. They work with S3 as well. Potentially, we can be integrated with them, and we are thinking about this. But we are trying to be consumer-driven, customer-driven, and the biggest need today is probably integration with MLflow, because MLflow shines really well in online metrics tracking side, and sometimes people like to use MLflow for tracking metric online, and DVC for version data files. And this is one of the integrations that we are thinking about today.
And so in terms of the actual implementation of DVC itself, I know that it's primarily written in Python, and you mentioned that that's largely driven by the fact that that is becoming the lingua franca for data scientists. So I'm wondering if, now that you have gone a bit further in the overall implementation and maintenance of DVC, if you think that that is still the right choice, and if you were to start over today, what are some of the things that you would do differently, either in terms of language choice or system design or overall project structure?
Regarding language, I believe Python is a good choice for such kind of projects for two major reasons. One, we are targeting data scientists, and most of them are comfortable with Python, and we expect a data scientist to contribute to our code base. And if you write this kind of project in, like, let's say, C or C++ or Golang, probably you won't see a lot of contribution from the community, because community speaks different language. For us, it works perfectly. Data scientists are contributing code, which is great. And second reason was programming KPIs. Before, we were thinking about creating a DVC through APIs. It's kind of another option of using DVC. And if we write code in Python, it kind of goes out of the box. You can reuse DVC as a library and inject it into your project. If you use a different language, it just creates some overhead. You need to think about like wrapping this into kind of a nice form. These were the major reasons. And so far, we are happy with the Python, and it works so nicely.
And you mentioned being able to use DVC as a library as well. And so I'm wondering if there are any use cases that you've seen that were particularly interesting or unexpected or novel, either in that library use case or just in the command line oriented way that it was originally designed.
Oh, sometimes people ask for library support because they need to implement some kind of a more crazy scenarios. I can say, for example, people use DVC to build their own kind of platforms, if you wish, data science platform. They'd like to build kind of a continuous integration framework when DVC plays role of this kind of a glue between your local experience and CI experience. And they're asking for libraries, but we had such a great command line support, command line tool set, and people just switch back to command line experience. But one day I won't be surprised if someone will be using DVCs just purely as a library.
And I'm also interested in what you were talking about of being able to integrate DVC into data engineering pipelines as just wrapping a single implementation step for running the model training piece of it. So I'm wondering if you can talk a bit more about that and some of the specific implementations that you've seen.
Yeah, absolutely. This is actually a really good question. I believe that data engineers need pipelines, right? And data scientists and machine learning engineers need pipelines. But the fact is, their needs are absolutely different. Data engineers do care about stable system. If it fails, the system needs to do something. It has to recover. And this is kind of a primary goal of the data engineering framework. In data science, it works kind of an opposite. You fail all the time. When you come up with some idea, you write code, you run this code, it fails, you fix it, it fails, and etc., etc. And your goal is to make a framework to check ideas fast, to fail fast. This is the goal of ML engineering. And this is a good practice to separate two frameworks of two kind of a pipeline frameworks. One is stable engineering, and second one, fast, lightweight kind of experimentation pipeline, if you wish. And when you separate these two worlds, you simplify life of ML engineers a lot. They don't need to deal with complicated stuff. They don't need to waste time on understanding how like Airflow works, how Luigi works. They just live in their world, produce models, and when the model is ready, they need a clear way how to inject this pipeline into data pipeline. And you can build very simple kind of a tool in order to do this. So I remember when I work at Microsoft, to me it took maybe like couple hours to productionize my pipeline because I have a separate workflow. I had a separate tool for ML pipelines, and it works nicely. I believe this is kind of a future of engineering. We need to separate these two things.
And I'm also interested in the deployment capabilities that DVC provides as far as being able to put models into production or revert the state of the model in the event that it's producing erroneous output or that the predictions or the results that it's providing are providing problems to the business, or just some of the overall tooling and workflow that is involved in running machine learning models in production, and particularly as far as metrics tracking to know when the model needs to be retrained and just closing the loop of that overall process of building and deploying these models.
Yeah, deployment is a very interesting area because it's close to business, and there are a lot of funny story about ML model deployment. Sometimes it goes like a software engineer asks for data science team, like, can we revert our model to not the previous one, but the model from the previous week? And data scientists like, yeah, sure, we have code, we have data sets, I need just like 5 hours to retrain it. And it does not make any sense, right? To spend 5 hours to revert a model. In software engineering world, it does not work this way. You need to have everything available, and you need to revert like right away, because wasting 5 hours means wasting money for business. And DVC basically helps you to organize this process. It helps. It basically creates a common language between your data scientists who produce the model and ML engineers who take model and deploy model. So next time, with a proper data management, you won't be even asking data scientists to give you like the previous model. You should have everything in your system, like DVC or not DVC, doesn't matter, but you need to have all the artifacts available. And from metrics tracking point of view, this is actually a separate question, because when you're talking about metrics tracking in production, it usually means online metrics. It usually means metrics based on feedback loop from users. And this is a separate question. So DVC, it's mostly about deployment, or not deployment, mostly about development phase. It today does nothing basically with online metrics.
And so you are actually building and maintaining this project under the auspices of iterative.ai, which is actually a venture-backed company. So I'm curious what the overall value equation is for your investors that makes it worthwhile for them to fund your efforts on building and releasing this open source project, and just the overall strategy that you have for the business.
You will be surprised how investors are interested in open source projects today. Today, especially the last year, was super successful for open source projects. Last year, MuleSoft was acquired for numbers of billions. Last year, Elasticsearch went IPO. It's purely open source company. And when you do open source, it usually means that you are doing IT infrastructure. In many cases, you are doing IT infrastructure. IT infrastructure is a good area for monetization. And with a successful open source project, there are a bunch of companies which are monetizing this open source. It's just important. It's very important to understand your business model, because with open source, there are a few common models. One is obvious service model, a kind of consultancy model. The second is open core model. When you build software and produce a piece of this software with advanced feature for money, or a different version of your software as a product for enterprises. And the third model is ecosystem. When you build a product, an open source product, and create services as a separate product. It's one example might be Git and GitHub. When you have open source and SaaS service, which is absolutely different product, is absolutely different experience and use cases. And you need to understand which model you fit in. And for successful project, a lot of VC are interested in this experience, in this kinds of businesses. Initially, I started the project as it was my pet project for about a year, and then I was thinking like how to make something big out of this, how to spend more time on this, how to find more resources in order to do this. And it was clear that this project, if it is successful, there few businesses will be monetizing this area. And why don't we be this business which builds a product and monetizes product? So it's kind of a natural path for a modern open source project, I would say.
And as far as your overall experience of building and maintaining the DVC project and the community, I'm wondering what you have found to be some of the most interesting or challenging or unexpected lessons learned in the process.
One of the lessons that I learned, I think it's a usual business lesson, actually. So when you build your project, you know what you do, you know your roadmap, you know your goal, and you are just building. But one day, users came to you, and they ask for a lot of different stuff. And then you have kind of a tension. You have a tension between your vision, your plans, and demand from user side. And today we reach the point when every day we have a few requests from users. Sometimes we had like 10 requests per day, and it's not easy to balance the things, because if you do everything people ask, you have no time for your roadmap, and actually you have no time to answer to fix and to implement everything that people ask. So you need to learn how to prioritize things. You need to learn how to sometimes say no to users and say, we will do this, but probably not right now. And so this is not easy to do. This is what you need to learn during the process. And as I said, it's not something new in open source. It was the same way in the business environment, and I have seen that for many times.
And looking forward in terms of the work that you have planned for DVC, I'm curious what types of features or improvements that you have on the roadmap.
Regarding the features for For the near future, we are going to release better support for dataset versioning and ML model versioning. We are introducing two new commands into DVC which simplify your experience. Today, some companies are using monorepo with a bunch of datasets inside. And we need kind of a new commands to version them better. Sometimes because these data sets are kind of evolving in a different speed, and you need to work with one version of those data sets, one version with another data sets. Sometimes, so basically, this is one of the steps we are taking. And another use case for data sets is cross-repository references. Other companies are not using monorepo. They're using a set of repos. For example, they might have like 10, 20 repos with data sets and 20 more with models, and they need to cross-reference the data sets. This is the next command we are going to implement to support this cross-reference, cross-repository scenarios. This is about near future. And in the long vision, the next step would be implement more features for better experiment support, especially when people deal with such a scenario as hyperparameter tuning, and they need to have, let's say, 1,000 experiments, and they need to still control them. They don't want to have 1,000 branches, and this experience we need to improve, and we have a clear plan how to do this. And that's pretty much it for the next maybe half a year. And eventually, we believe that DVC can be this platform when people can work on the same environment in one team and share idea between each other. And in the future, we believe we can create great experience when people can share idea even between companies, between teams. This is the big future of DVC that I believe in.
And are there any other aspects of the work that you're doing on DVC or the overall workflow of machine learning projects that we didn't discuss yet that you think we should cover before we close out the show?
I don't think I have something to add, but what I believe in, we need to pay more attention on how we organize our work. We need to pay more attention how we structure our project, where we need to find more places when we waste our time instead of doing actual work. And this is very important to be more organized, more productive as a data scientist, because today we are still on the Wild West and it needs to be changed as soon as possible. And it is important to pay attention to this. It's important to understand this problem set.
All right. Well, for anybody who wants to follow along with the work that you're doing or get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose a tool that I started using recently and experimenting with called Otter.ai. And it's billed as a voice note-taking service that will transcribe your meeting notes or just mental notes to yourself to text so that they're searchable. And I've been experimenting with using it to try out generating transcriptions for the podcast. So I'm looking forward to start using that more frequently and starting to add transcripts to the show. So definitely worth checking out if you're looking for something that does a pretty good job of generating transcripts automatically and at a reasonable price. So with that, I'll pass it to you, Dmitry. Do you have any picks this week?
So I thought the open source part and open source versus venture capital, it is the question that we will discuss. Actually, I have nothing special to suggest, but today it's nice weather. It is spring just started. I suggest spend more time outside, reading outside and walking around the city or town.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you're doing on DVC and adding some better structure to the overall project development of machine learning life cycles. So thank you for that, and I hope you enjoy the rest of your day.
Thank you, Tobias. Thank you.